discuss more about the conditional statement. Then we shall review the conditional statement. We shall also look at some variations of the conditional statements. And then we shall make some conclusion about those variations of the conditional statement. Please, it is very important. It is highly recommended that you view the videos in the playlist, beginning from part 1 through 4 before you view this one. We shall also talk about the logical equivalence that we did in part 4. We shall also discuss that in this video as well. So let's look at the conditional statement. If P, then Q. Let's look at the conditional statement. If P, then Q. This could be written in several words, several words. You can, of course, you can write if P, then Q. You can also write if P, Q, even if you don't put then Q. You can also say if P, Q. Another way you can write this statement is number 3, P implies Q. Number 4, P is sufficient for Q. Number 5, Q is necessary for P. In mathematics, there is what we call sufficient conditions and necessary conditions. It is an important concept in some mathematical theorems. It involves the conditional statement. You also see this conditional statement in computer science, in programming languages. When you look at your conditional statement, if combo box, if maybe if rate combo box dot text is percent, then rate will be rate value divided by 100. To change it to decimal, we have done videos on that. We use the if then is a conditional statement. If then else if. So the conditional statement is a very important statement in logic. Among all the statements we've discussed so far, it is one of the most important statements in logic. And we shall look at the variations of it so that you can see the importance as well. We shall discuss these as we move on. Number 6, you can also write this as Q if P. Q if P. Q if P. Number 7, you can write it as Q when P. When P. I hope you're seeing this. This is if P, Q. But this one is Q if P. The next one is Q when P. These are the ways you can write this, These are some of the ways you can write this statement. Now, we are going to give an example, then we can go to variations of a conditional statement. So let's go ahead and give an example. Let's say you have P to be you love your neighbor. I think this is American English, whereby it is not a B-O-U-R, B-O-R, neighbor. Likewise, labor, L-A-B-O-R, but British English, L-A-B-O-U-R. I think the same thing applies British English. You put you, but American English. Okay? You love your neighbor, P. Then Q, you shall see God. You shall see God. So let's write these statements in various forms. These are some of the forms, not all of them, but some of them. So the first one, if you love your neighbor, if you love your neighbor, then you shall see God. You shall see God. Right? Yeah, go, Sam Don, go. Preach. If you love your neighbor, you shall see God. Then you can write if you love your neighbor, you shall see God. You shall see God. If you love your neighbor, you shall see God. Another way to write it is, to love your neighbor implies to see God. To love your neighbor, implies to see God. Next one, P is sufficient for Q. To love your neighbor is sufficient to see God. To love your neighbor is sufficient to see God. Q is necessary for P. To see God is necessary for you to love your neighbor. It's necessary for you to love your neighbor. For you to love your neighbor. And this could be, to love your neighbor is sufficient for you to see God. To see God is necessary for you to love your neighbor. Okay? Now, to love your neighbor is sufficient for you to see God. Sufficient for you to see God. For you to see God. Q if P. You shall see God if you love your neighbor. You shall see God if you love your neighbor. If you love your neighbor. Then Q, when P. You shall see God when you love your neighbor. You shall see God when you love your neighbor. We need to love so that we can live peacefully in this world, you know. We need to love our neighbor so that there can be peace in this world, you know. This is, you know, the conditional statement, and these are the various ways you can write it. Okay. Now we are going to look at some variations of the conditional statement, and we will see the relationship between those variations. So let's go back to this conditional statement. Let's say when we interchange it, that's the first thing we shall do. We interchange it, and we'll look at the way it will be. And then the next thing we will do is to negate it. We'll look at the way it will be. Then the next thing we'll do is to interchange and negate it. Interchange it and negate it. Interchange it first and negate it. Interchange it and negate it. We will see what it will be. So if we interchange this, P implies Q, interchange. If we do that, then what are we going to have? We'll have Q implies P. If we interchange it. That is what we are going to have. Q implies P. If we negate this, negate it, then it will be negation of P implies negation of Q. Then if we interchange it and negate it, we have to interchange it first, then we negate it. It will be negation of Q implies negation of P. Okay, now let's look at this. Let's look at these variations of the conditional statement. Let's study it, and it's very important. Let's use another example. Yeah. So I've preached the word of God. Love your neighbor. Now let's look at another example here. Let's do some history. Let's do some geography. P. I live in Nigeria. Q. I live in Africa. Okay, let's do the conditional statement. P implies Q. It will be what? If I live in Nigeria, then I live in Africa. If I live in Nigeria, then I live in Africa. Right? That is true. Now, if we interchange it, Q implies P. Q implies P. Right? So this is true. This is true for those of us that know history, right? Okay. Because Nigeria is in Africa. Q implies P. If I live in Africa, then I live in Nigeria. Now, if you analyze this statement, it is not necessarily true. It is not. It is not necessarily true. Not necessarily true. Because not necessarily true. You know why? Because if you live in Africa, you can live in Ghana, you can live in Kenya, you can live in Zambia. You must not live in Nigeria for you to live in Africa. You must not. So this is not necessarily true. Now, not necessarily true. Now, this is what we call the converse. Converse statement. Converse. Converse. Say converse statement. Let me use marker. This marker right here. Converse. Converse statement is the converse. This is the conditional. And the converse statement is If I live in Africa, then I live in Nigeria. That is what we call converse. Converse. Now, the negation, not P, implies not Q. If I do not live in Nigeria, then I do not live in Africa. If I do not live in Nigeria, then I do not live in Africa. Now, if you look at this also, you see that it's not necessarily true. You know, because if you do not live in Nigeria, you might be living in Ghana. And if you're living in Ghana, that means you're living in Africa. Okay, now if you don't live in Nigeria, you don't live in Africa. I mean, it's partially true, but not necessarily true. It's not necessarily true. Because you might live in Benin Republic, it's still in Africa. So this is not necessarily true. Not necessarily true. Not necessarily true. And this is what we call the inverse. Inverse. Say inverse. Inverse statement. That is the inverse statement. Inverse. Converse, inverse. Then the next variation, these are variations of the conditional statement. Variations. The next variation is not Q implies not P. If I do not live in Africa, then I do not live in Nigeria. If I do not live in Africa, then I do not live in Nigeria. Okay? If I do not live in Africa, then I do not live in Nigeria. That is true. If you don't live in Africa, that means you're not living in Nigeria. I mean, if you look at it, it's true. You know? But some of you might doubt, hey, whether it's true or false or not necessarily true. But we'll see. If you live in Nigeria, then you live in Africa, which is true because Nigeria is in Africa. Now, if you do not live in Africa, that means you do not live in Nigeria. Now, some of you might say, okay, you're not sure whether it's actually true. You know, at first hearing it at first time, you're thinking whether will I say true or not necessarily true. That is where we are going to prove it now. We are going to see whether this is true or false. Now, this is what we call whether this is true or not necessarily true. Actually, we're not looking at it to be false. You know, we want to see whether it is true or not necessarily true. And then we want to see whether some of these statements are logically equivalent to each other. We want to see whether one statement is logically equivalent to another statement. Okay, that is what we want to do. So this interchanging and negating is what we call contrapositive. Say contrapositive. 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 So we have the converse, inverse, and contrapositive. These are the variations of the conditional statement. Now, what are we going to do? We are going to find out, we're going to draw a truth table. You see, as we talked about earlier on, truth table has so many applications. We're going to draw a truth table to find all these. We'll do a truth table of all these. So I would like you to still keep note of this. We want to write whether it is true or not necessarily true. So still keep note of it. but I'm going to erase this. We want to draw a truth table of all these statements, the conditional statement, the converse statement, the inverse statement, and the contrapositive statement, so that we can look at the relationship, if they have any relationship. And then next videos we can solve problems. I just want you to understand this concept before we now solve problems. So let's draw a truth table of all these statements. We have P, we have Q, we have P implies Q, we have Q implies P, that is the converse. Then we have negation of P, we have negation of Q, we have negation of P implies negation of Q, and we have negation of Q implies negation of P. So, as usual, the way I draw my logic and truth tables, I draw two lines as usual. Then we of course we have true, false, false, and we also have true, false, true, false. All right, I know we discussed this in previous videos, but let us see whether we can do a rewind. Let's rewind it again, so we make sure we put in the correct values on every one of them. Let's kind of have a refresher on the conditional and biconditional statements. We have P, we have Q, we have P implies Q, we have P if and only if Q. This is the biconditional. Now, if you remember, if you can recall what we did earlier on in the previous video, true, false, we used the case of Hurricane Sandy and power lines will be cut off, right? We kind of said if P is Hurricane Sandy, will hit, and the Q is power lines will be cut off. So we are looking, the precedent and the antecedent. If Hurricane Sandy, so a news anchor came and said, if Hurricane Sandy hits, then power lines will be cut off. That was what the newscaster said, right? So Hurricane Sandy hit, power lines were cut off. So what the news anchor said was true. So both of it are true. Hurricane Sandy hit, power lines were cut off. So what the news anchor said was true. Now, what if the news anchor said, if Hurricane Sandy hits, power lines will be cut off, right? Then Hurricane Sandy now hit, but power lines were not cut off. Okay, the public will say, okay, why did you tell us that power lines will be cut off? That is what the public will say. Why did you make such a false statement? Right? Because the news anchor said, if Hurricane Sandy hits, then power lines will be cut off. That was what the news anchor said. Okay, Hurricane Sandy now hit, which is true, but power lines were not cut off. Power lines will be cut off, but in this case, this is false. Power lines were not cut off. So maybe if the news anchor didn't say that power lines will not be cut off, then maybe the school system might still say, let us go to school. Even if there is hurricane, they might say, let us go to school. But the school system will not go to school if there's no power, because everybody will be in the dark. Schools will not function. So they will now ask the news anchor, why did you give us such? And that is false, because that is where the news anchor will now have to answer question. Now, if Hurricane Sandy did not even hit, now you don't blame the news anchor, because the news anchor said if Hurricane Sandy hits, then power lines will be cut off. That is what the news anchor said. But in this case, Hurricane Sandy did not even hit. So we don't really care whether power lines were cut off or not, because the news anchor said if Hurricane Sandy hits, power lines will be cut off. But Hurricane Sandy did not hit. It did not hit. So it did not hit. The news anchor will not be to blame, because she said if it hits. So this will still be true, and this will still be true, because the news anchor said if it hits, but it did not hit. So whatever happens is okay. The news anchor is good to go, because the news anchor said if it hits, but the Hurricane Sandy did not hit. So it's still good. But in the biconditional, both terms are important. Both terms are important. So when you have this is true, this will be false, this will be false, and this will be true. That is the difference here. Okay? With the biconditional, both of them, must be true. When both of them are true, that's fine, because this is a P if and only if Q. Now, if both of them are false, that's okay. If it did not hit, that's okay. That will be true. And then these two cases will be false. Now, let's get back to this, because this is what we want mainly. The conditional is our main focus. Now, this is the conditional. This is the conditional here. This is the converse. This is the inverse. And this is the contrapositive. Contrapositive. Now let's look at them, okay? So this will be true, this will be false, this will be true, and this will be true. Here, Q implies P, T implies T is true, FT is true, TF is false, FF is true. In this case, negation of P, this is F, FTT. Please view my videos on previous videos, please. You will understand it. This is false, this is true, this is false, and this is true. Then negation of P implies negation of Q, F implies F is true, F implies T, this is still true, this is false, and this is true. Then FF here will be true, TF here will be false, FT will be true, TT will be true. So look at this now. Look at these statements. You will notice that the conditional statement here and the TFTT, TFTT and the contrapositive here are logically equivalent. Okay? Conditional statement and the contrapositive statement are logically equivalent. Okay? Conditional and contrapositive are logically equivalent. So what does this tell you? This means that in logic, in argument, when you argue cases, you can replace the conditional statement with this contrapositive, and the argument is still, will still be legally valid, logically valid. Okay? This means that because they are logically equivalent, you can replace the conditional statement with the contrapositive statement and still retain the logical meaning. You can still retain the logical meaning. Similarly, you can also, if you look at the converse statement here and the inverse statement, TTFT, TTFT. Similarly, the converse, right, and the inverse are logically equivalent. Logically equivalent. So that means that you can replace, in logic, you can replace the converse statement with the inverse statement, and it will still retain its logical meaning. Please, in the next videos, we shall solve problems that deal with the logical equivalence as well. Okay, now, as we mentioned earlier, logical, so we shall be solving it.